So just in structural loading terms, there's really two major categories when we're talking about weight. One of those is dead loads, or constant loads that are on a building. And those are weights, materials, equipment, or components that are relatively constant throughout the structure's life. So HVAC equipment, the membrane, pavers that might be up there, a gravel ballast system that might be up there in order to hold down that membrane. And then there's also live loads or intermittent loads that need to be considered, and those are water, irrigation, snow, rainfall, people, if you're up there maintaining the equipment or looking at the Ecoroof, those kinds of things. So those are just two terms we talk about, and really the Ecoroof things that we talk about fall into that dead load category. And water that may be, or rainfall that may fall on the rooftop and is intermittent will be considered a live load, as it will percolate through the soil and run off of it. But when we're talking about those weights of these soils, we're talking about a saturated condition, because they may be saturated for a few months at a time.
So the soil is considered a dead load, the water that's saturated in the soil is considered a live load?
A saturated soil is considered a dead load, and then the water that falls on it and through it is considered the live load. So what we have here is just a variety of weights of different materials that may be used in a typical Ecoroof, and some of those are just for reference. So water, these are in pounds per cubic foot, so a 12-inch by 12-inch by 12-inch cube of this material. And the one I wanted to point out, so we've got water at 62 pounds per cubic foot. Silty loam is, at 70 to 75, and when that gets saturated, it gets up to 100 to 120 pounds per cubic foot. Then you can see on the right, pumice, which is used often in Ecoroof mixes, is at about 40 pounds per cubic foot. Rubber, being the membrane, 40 or 60 mil is about 100 pounds per cubic foot. And then, but a cubic foot of rubber, that's quite a bit of rubber, so usually they're fairly thin. Asphalt, being 45 pounds per cubic foot. And then I wanted to point out on this one, gravel, wet gravel is 125 pounds per cubic foot, and that's oftentimes what we'll talk about is gravel ballast roofs. So we'll come back to that number in a minute. But I did want to point out that with pumice up at the top there, so 40 pounds per cubic foot, if we wanted to get that in maybe a number that we understand a little bit better, let's just divide that by 12. So that number is 3.33. No, I already had it up here. So 3.33 pounds per square foot at a 1-inch depth. Does that help a little bit? So then if we did 4 inches of that, we're at about 10 pounds. So 10 pounds per square foot at a 4-inch depth for that number at pumice. Now, pumice, of course, can vary depending on the coarseness and those kinds of things. But that just gives you a little bit of idea. And then plants on top of that, so we're at about a 10-pound roof, let's say, and then plants on top of that can be like 1 to 2 pounds. So we're right there, we're at about 11 to 12 pounds per square foot, just with pumice and plant material.
13.
That was, yeah, a little bit more than that.
It was a little
Sorry, you're right. Thank you. 13.2. Whoever has a calculator out there. That's good.
That was the test.
Yeah, it was a test. It was hard. So in general, what we need to know is that we need to understand the structural capacity of the building structure to support the additional weight of the Ecoroof. And I talked about soil and plants being the dead load, and then water, of course, not being part of the roof assembly. So we're talking in general, after everything's said and done, a range of 15 to 30 pounds per square foot for an Ecoroof. And we're talking saturated weight, so that gives you that dead load. And of course, the Ecoroof is going to be lighter as water evaporates and transpirates off.
Now that 15 to 30 includes down to the membrane? Or from the membrane up?
From the membrane up, yeah.
Okay.
And that's a range. There's quite a few different weights out there, that, but 15 to 30 I think is just a good rule of thumb. So I talked a little bit about various soil compositions. In general, we heard that from Seattle that maybe 4 inches is the optimum depth, but in reality, 4 to 6 inches appears to be pretty good. Of course, depending upon soil composition, Tom talked a little bit about the monitoring results that we were getting on those various soil depths, and they range. And I think there's many issues involved or things to consider when we talk about the performance of these Ecoroofs. But generally, I'd say that a 4 to 6 inch composition of a pumice mixture is going to be lighter than a 4 to 6 inch mixture of sandy loam. Now, whether those are going to perform better for stormwater management, we don't know specifically, but those are definitely going to have different weights. And so what we're getting, though, right now is about 50% reduction on average of this 4 to 6 inches that we have across Portland. And we noted that just a recent book that came out about Malmö, Sweden, that they're also getting 50% reduction as well. So I think that's pretty interesting. So to give you a range of just what's out there right now, soil depths and weights, we've got about 2.5 inches, or used to be 2.5 inches, Tom, right, on your garage. And you want to talk about that at all? No. Okay, not right now. Okay.
Next week.
Okay, next week. We'll save it. And then, so Metro being at 3 inches, about 15 pounds per square foot. Portland building, this building, 3 inches at about 15 pounds. Hamilton West at 5 inches at 25 pounds, and then Multnomah County at 6. And so really what's interesting is that most of these are all still kind of within similar weights because the depths do range different. You can see with Tom's roof at 2.5 inches at 20 pounds is a little bit more of that garden loamy mix, considering he was taken out of his yard and thrown on his roof. It was a highly technical mixture of soil, but nevertheless still effective and beautiful.
Is there any, maybe I'm way ahead of myself, but on the soil, it's not, I got the impression here it's just the same, but if you were to intentionally wish to have drainage, wouldn't you have like coarser material at the bottom and kind of built up to more?
Yeah, there's a lot of different systems out there that, because the dichotomy is we need to get rid of the water because we don't want to hold too much and make it too heavy. But then on the flip side is we need to hold some of that water for the plant material. And so there's all these different soil mixes that are out there that have a water retention capacity, but also then shed water well. And perlite or pumice does a good job of that, and that's why our perlite or vermiculite or expanded clay is often used as well, as those clay pots, it'll absorb that water, but then also be granular in a sense, so any of that water, excess water, is going to flow right through. But we'll talk a little bit more about soils later. And so on new buildings, when it comes to structural loading, any new building is must be designed to hold a particular load. And the additional 15 to 30 pounds, I would say, may require an additional upgrade of the structure. And what we're thinking is that sometimes, depending on if it's a wood, steel, or concrete system, that additional structural loading may be no money because it may have already been designed to hold a gravel ballast roof, or maybe up to $5 a square foot for that building footprint for additional loading. But our recommendation, because we'd love to live in this world, is that we just say, hey, just design it for an Ecoroof. If you don't put it on there now, let us know, and maybe we'll put it on later in a few years. So existing buildings, this is the Portland building before the Ecoroof was placed on it. Is that right, Tom? Oh, Multnomah County, I'm sorry, yeah. And the question here on existing building is, can the existing building hold this additional weight? And this Multnomah County had a 15 pounds per square foot gravel ballast roof. And just to go back real quick on the numbers that we had, remember that gravel wet was about 125 pounds per square foot, or per cubic foot. And for those of you with the calculator, if we divide that by 12, that's going to be, 10 pounds per inch. And so let's say that's a 2-inch gravel ballast roof when wet. So it's about 20 pounds per square foot for that gravel ballast. So this roof could already hold that gravel ballast roof, so why not be able to take all that gravel off and just replace it with an Ecoroof, and the weight isn't any different. So obviously hunting for the gravel ballast roof in Portland is one thing that we do continually if we're out high up on buildings looking around trying to find where those gravel ballast roofs are. There's not too many out there. I know one project we're looking at right now is Portland Community College down on Water Avenue and southeast there. They have a gravel ballast roof on their building, and so we're going to look at putting an Ecoroof there.
I think in terms of existing buildings, for those of you who might have clients or building owners, over the years, a lot of times a building can be constructed with a ballast roof, and then when it's re-roofed, often they won't put the ballast back. So some buildings have been made strong enough to hold this extra weight, but they might have a conventional membrane on it now without the gravel. So if you see a building that doesn't have gravel, that doesn't mean that it wasn't designed for gravel if it's an older building. So it's always good to just check a little bit further. But that gives you an idea. If it's got gravel, then you know right off the bat. But don't think that if it doesn't, it may not be strong enough. It's still something to check.
Well, and that
might be.
Right, and that one example we found out just from the building maintenance supervisor, I think it was, that he had been there for years and said, oh yeah, there used to be gravel up on this roof. Nobody else in the building knew because they had been either new tenants or had changed over the years, but there was one person that was there that knew that, yeah, we pulled off, I don't know how many pounds of rock, he said, came off of that roof. Yeah, that's a good point. So, what structural upgrades would be necessary to accommodate the additional weight with these existing buildings? And we just say that I think there's a lot of buildings that are out there that we are going to bring in with the grant applications. And new construction, of course, there's going to be structural engineers involved. But for existing buildings, we'd say get a go, no-go from a structural engineer. You know, call them up and say, hey, just can you come out, take a peek at my building, and let me know, are we close? Is it possible? Because I think that we can cull through quite a few of these existing buildings that are out there and determine whether or not they can hold this additional weight. But I think it's worth just getting a hold of them, and we're going to have some structural engineers on our resource list on the web that you'll be able to call and just try and get some of that information from. Either obviously hire them to come out and do an evaluation. And then if they give you maybe a go, no-go on that, then you can say, okay, it's possible, then what structural upgrades do we need, and have them do a design for you. Obviously, you know, some of those industrial buildings, it's going to be a lot easier because there's open access potentially to those structural members. So the cost for those additional structural upgrades may be less than if you had a full-blown office building where there's, you know, drop ceilings and the structure isn't exposed, I guess. But, you know, there's one building we're working on, just 10,000 square foot building, just on the east side, and it's kind of a old commercial building that's been in second generation owner of this business. And the bottom floor, you couldn't really see much of the structure, but if you went up above in the second floor there, it was just a big warehouse space for them, and you could see all the open exposed beams and concrete walls and stuff like that. So anyway, it's definitely worth doing an evaluation. And then I wanted to point out that, of course, our resource list is there, and the other thing was I brought along these guys. And for those of you who are interested, it's not terribly exciting reading, but ASTM standards, American Standard, Standard Testing of Materials, has come out with a standard practice for determining dead loads and live loads associated with green roof systems. and that's section 2397 of ASTM, and I think you can go to astm.org. I think that's it. And then, what was the other one? Yeah, I think that was it that I just wanted to point out for structural live and dead loads associated with that. So that'll just give you a good reference point if you're interested in getting a structural analysis. It's not required or anything like that, but it might just be some good reading and be a little bit more informative as to what you might ask a structural engineer for, or if they haven't done an Ecoroof before, it might give them a little bit better knowledge as to what is required of an Ecoroof for that structure.
So what would that standard have in it that's particular to an Ecoroof over and above any other type added structure on it?
I don't know exactly what it would, because that was my question as well. Is that it seems that the structural weight is weight, and they're going to evaluate that stuff. So as for the specifics of it, I can't comment on that. Yeah. All right. So I think that's it in general for structural loading. Are there any questions on that? Or any more questions on that? Yeah.
We've got a deal in here that investigate seismic capabilities for the existing structure. Are they going to require a seismic upgrade if you do any upgrades?
I don't know. If you're doing, I think if you're doing a renovation, most likely yes.
If you're just doing this to add for your eco,
It might.
so they're going to make you take it over the current code.
Yeah.
So Peter Drake is going to help address some of these questions next week, and
Yes, it will.
going to do a presentation on permitting and such.
Is
So.
that a large cost feature?
Can be. Can be.
Right.
Yeah. Right. Anything else? Yeah.
Do you actually need a landscape architect involved with Ecoroof?
No. No. I don't. That's a really good question as to who's required to be involved. I suppose if you have a structural engineer sign off on a building, then you can have a roofer install an Ecoroof for you.
And you have a resource listing contractors whose experience in Ecoroof.
Yeah, we're currently developing that. That's part of my job at the city is contacting installers as well as product reps as well as nurseries and those kinds of things to include on the resource list for people to say, hey, just give me a ring, I'll help you out, or be able to give prices and those kinds of things.
Part of it too is, and we'll talk about this next week in the design portion related to the plants, but depending on what you or your client wants to do, that sort of helps you determine who you might talk to. Because if you're, for instance, if you're one of these big box buildings and you're just putting a utilitarian Ecoroof for that purpose, it's utility, then you don't necessarily need a landscape architect to help you pick all the plants and things. There are numerous companies that have their own products that they will say, well, here's my whole product, my whole system, just buy my system, things like that. So.
And before I forget, I wanted to just point out that this here is kind of Germany's ASTM standard for green roof systems. It's called the FLL guidelines. And as to where to get it, I think I Googled it, found it in a couple of places. Tom, I think you got this one sent to you, of course, by one of your many contacts all over the world. But you can find it and purchase it. And this one is in English, and it was updated, I think, in 2004. And it's a really interesting read because you realize quickly that there's a lot of information in this just about green roofs and structurals and water capacity of soils and those kinds of things. And it's not necessarily stating this is how you should do it. It's just, in general, these are some guidelines that you should look for when you're doing your green roof. So
It does have testing information. They do require testing of membranes, and they have a rating system for membranes, which is a pretty important question. We'll talk more about that later today when we talk about membranes.
mm-hmm. It's just called the FLL guidelines, and FLL stands for something in German, and I don't speak German. For somebody who might, this would be great. They're really long words, all three of them. I would attempt it, but no, I would hurt somebody. So
You can
anyway,
take a look at the document.
yeah, it'll be up here on the table
lunch or the
and
break.
come up and take a peek. But for anybody who's doing green roofs, I would say just read it. Pick it up and read it, because I think it's really interesting. Was that it for this? Yeah, I think so. Okay. Yeah.
On the resource thing, you know, one thing would be great, just a suggestion, is like engineering firms for large projects and engineering firms for like residential projects, so that we don't send people calling to the, you know, if somebody wants a residential home upgraded, I'd rather send them to somebody that's willing to take on smaller projects. So that would be.
Yeah, that's a good suggestion. I think because there'll be a whole range. I think even from contractors and nurseries and whoever else. So that's good. No, that's a good suggestion.
We'll probably have three. We'll have the one that does commercial only, residential only, and then the ones that do commercial and residential, something like that.
Right.
Which quite often you get most of them in the commercial and residential, because business is business. And
Yeah. I don't want to be in a category or not.
I can do that.
Yeah. Anything else on structural? Good? Okay. All right, we're going to move on to a little bit more on the specifics of the Ecoroof design.